According to the World Population Prospects 2022, the world population is projected to reach 8 billion by November 15th of this year, and India is expected to take the first place in the world's most populous country by 2023, surpassing China. The United Nations then suggests a projected growth in the population to around 8.5 billion in 2030 and will increase to 9.7 billion by 2050. By 2080, it will reach its peak to around 10.4 billion people and will remain at that level until the 22nd century. But how are these numbers relevant to population? What are the factors and processes that affect population growth? And are those constructed graphs and tables on population dynamics important? First of all, we would like to present this mind map comprising all the topics and subtopics regarding population and population dynamics, which includes population types, population dynamics and demographic processes, population growth, and population regulation. To start off, let's have a review of population. A population is a group of individuals of a single species inhabiting a specific area at the same time. It has two types, semiparous and heteroparous. In semiparous populations, there is no age structure as the individuals are of the same ages, a product of only one reproductive period during the entire life cycle. Meanwhile, in heteroparous populations, age structure is exhibited as several reproductive periods are present.
Population dynamics looks at how the population of the organisms changes over time. It studies population growth and size while taking into account the different factors constituting the increase and decrease of population, creating the total growth rate. Additionally, it adds up to the conversation, control, and maintenance of the different populations. Predictions regarding the changes in population are determined through the statistical study of populations, termed as demography, including the four non-mutually exclusive demographic processes, namely birth or natality, death or mortality, immigration, and emigration. Population increases because of natality or the birth of an individual and immigration or individuals moving into the area, both of which contribute to the addition of organisms in the population. The population decreases, on the other hand, because of the opposite, mortality, which pertains to the death of an individual, and emigration or the movement of organisms out of the area. In addition, one factor that can initiate the emigration of the organisms is the dispersal mechanism, which occurs due to the adverse or unsuitable environment conditions in the former habitat. Life tables are tools used to summarize the natality and mortality rates of organisms at a particular stage in their lives. On the other hand, graphs called survivorship curves display the percentage of a population that lives from one age to the next, and are divided into three according to shapes. In a type 1 curve, the majority of mortality happens among the older individuals, while the younger ones have the higher survival rate. As for the type 2 curve, the organisms involved have a constant mortality or survival rate across their lifetime, while type 3 pertains to the high mortality among the young organisms, wherein survivorship is requited with long life and lots of offspring. Meanwhile, age-sex structures refers to the snapshot of populations across time, wherein the distribution of their members based on age and sex is reflected through a population pyramid. There are four types of population pyramid, wherein the growth, stability, or shrinkage of the human population is linked. Having a sharp pyramid shape, rapid growth has a larger fraction of younger individuals that are most likely to be in reproductive age. On the other hand, slow growth refers to a larger fraction of older people than the younger ones, showing a pyramid shape. As for the stable age structure, it has a dome or silo shape, meaning there is a zero population growth, and the percentage of middle age and old people is greater compared to that of the slow growth. Finally, the shrinking population. This type of population possesses a dome-shaped top that pinches inwards towards the base, which implies that young individuals are only a small fraction of the population. An example of this type would be Japan, which is also said to be an older population.
Population growth is the increase of the number of people or organisms in a population or dispersed group. There are inherent or intrinsic population growth mechanisms which arise because of the reproductive ability of individuals of the population. This is computed using the formula here, where the number of individuals in the population and the population at a future time equals birth plus immigration minus death plus emigration. Biotic potential is the property of populations to multiply, which deals with an organism's maximum reproductive rate. This is high in most species and is influenced by sex ratio and age distribution. A favorable environment would unleash the species' full biotic potential, thus increasing the population. Ecologists determined methods to determine the population at any time, denoted by NT. As an example, if the Philippine population changed from 97.2 million in 2012 to 110.8 million in 2021, the percent increase in population is 1.55%. In the Lotka-Volterra equation, the rate of change in the population is the intrinsic rate of increase times the number of individuals. If represented in a graph, it shows a J-shaped curve to depict the population growth in which the population size is increasing indefinitely. Limits to population growth can lower birth rates, increase death rates, or lead to emigration within the carrying capacity of the environment denoted by K. From the original formula, the growth changes from exponential to logistic, showing an S-shaped curve. With unlimited resources, exponential growth is exhibited, resulting in a J-shaped curve. While with limited resources, populations exhibit logistic growth in which population decreases as resources become scarce. It levels off when the carrying capacity of the environment is reached, resulting in an S-shaped curve. There are four stages in population growth. Starting with the lag phase, the population is small but resources are abundant. This leads to rapid growth and faster consumption of resources, the exponential phase. When the carrying capacity or limit is reached, there is zero population growth as seen in the stationary phase. Lastly, the decline phase is when the population has exceeded carrying capacity. Environmental resistance factors are limits to population growth. It is influenced by the environment's carrying capacity, which is being continuously increased and extended by human beings through technology. Knowing limits to population growth helps draw the line in the population's carrying capacity. Without it, the population would increase uncontrollably as in exponential growth. Also, this limit would ensure that sufficient resources are shared within the population, avoiding mechanisms which decrease the population even more.
As seen in the 2016 population pyramid representing the age-sex structure, the Philippines exhibit rapid growth. Same is true with the years 1970 and 1996, the former having a broader base which indicates a very young population and high birth rate. In humans, the population belongs to different ages as a result of minimal births at every reproductive stage. The age structure is then divided into three ecological periods. In the pre-reproductive period, the population is prepubescent and unlikely to have the ability to bear children. Next, we have the reproductive period, which is crucial to population growth as the individuals belonging to this stage have the utmost contribution to the increase in population. Lastly, the post-reproductive period is when fertility declines and bearing of children is unlikely. As an implication, 30 million women in the reproductive age contribute to population growth every year. One effective way of decreasing population growth would be to increase the age of women bearing children from 15 to 25 years of age. This could be achieved through education and counseling. Another important aspect we could derive from the age structure is the age dependency ratio. This is the ratio of dependents, people younger than 15 or older than 65, to the working age population, those ages 16 to 64. In the Philippines, the total dependency ratio is currently 63.7%, and the child dependency ratio is 56.7%. Thus, the Philippine government needs to invest more in schools. In education, an implication of high population growth is the lack of classrooms in public schools, which leads to crowding. Thus, our government needs to build more. High population growth is also closely related to economic development, unemployment, high dependency ratio, and exploitation of natural resources. One consequence of the high population growth and flawed economic development is the destruction of fishery resources and marine environment. Additionally, the study of Porter and Ganapin from 1988 states that there was a rapid population growth, an elite-centered political system, and ecologically and socially flawed development strategy, which led to massive deforestation and environment degradation, which directly affects the rural poor and the dependents. One example of massive deforestation was the significant decrease in the Philippines' forest cover. As studied by Moya and Malayang in 2004, wherein the original total number of about 30 million hectares of the forest cover in the 1900s significantly dropped to almost 5 million hectares in the 1990s. This is the result of the environmental degradation and destruction, wherein people destroy forests due to four primary reasons. First would be the agricultural land conversion, which includes the Kaingin system. The second would be the foreign exchange generation, wherein people generate income from the exporting of natural resources from the forests. Included also in the reasons are conversions of forests to residential areas, primarily due to the increasing population and mining operations, which generates jobs for the locals and at the same time generates income from foreign exchange and export of the minerals. Consequently, these acts resulted in much more serious problems, such as the worsening case of pollution in land, water, and air, and the catastrophic effect of climate change. The Philippines is one of the mega biodiverse countries in the world. However, due to deforestation, the country is facing loss of biodiversity as a result of the habitat destruction of the species. There are four factors of environmental degradation. The increasing population growth results in the increasing population pressure. Due to poverty and the lack of livelihood opportunities, people rely heavily on the natural resources and with the open access of bioresources, wherein almost everyone have the access, and due to the fact that there's not much limit in accessing these, coupled with poor management, our resources are usually subjected to exploitation, destruction, illegal action, etc. Two important government actions to elevate the effects of high population growth and flawed economic development are as follows. The total fertility rate, or TFR, is the average number of children that would be born to a woman over her lifetime. This is influenced by social factors such as women's literacy and economic well-being. In 2016, the TFR of the Philippines was 3.1. This means that, on average, a Filipino would bear 3 children, remaining one of the highest in the whole Southeast Asia. The TFR was even higher in 1996 and 1970 with 4.14 and 6.53 respectively. The Philippines is aiming for zero population growth or ZPG, a condition of demographic balance where the number of people in specified population neither grows nor declines. With a TFR of about 2.2, a couple would only have 2 children. This is predicted to happen by the year 2050. As seen in the 2050 population pyramid, the base is narrow and almost even with the upper part, indicating a stable growth as a result of replacement fertility level in which 2 children replace their parents as a part of the population. The number of individuals moving up to the reproductive period is equal to the individuals being born. With the proper implementation of the reproductive health law, age-appropriate sexual education will be provided in schools, access to family management methods will be available for everyone, and the period to reach ZPG will be shortened.
Population size and growth are limited by many factors. Some are density dependent, while others are density independent. The density dependent limiting factors tend to be biotic and include population competition, predation, disease and parasites, and waste accumulation. In a small population, a limited amount of food would be plenty for the individuals, but a population increase would lead to scarcity, competition, and even death, as the food will no longer be sufficient. With a higher, more significant population, various limits emerge based on the environment's carrying capacity. This limits the population growth as the maximum carrying capacity is reached, causing the population size to shrink. Another type is the density-independent limiting factors, which are mostly abiotic, caused by natural disasters, severe weather, and pollution. The strength is independent of the population density. Take a forest fire as an example. The fire would not care about the number of organisms living there, and would not make any adjustments to regulate the population. Organisms inhabiting the area are independent figures who cannot do anything but adapt to the changing environment. This leads to abrupt shifts in the population size. Populations can fluctuate in density in many different patterns. Even without the abiotic factors, populations do not always have a stable carrying capacity. Some populations undergo cyclical oscillations in size, or the repeating rises and drops in the size of the population over time. Usually, these oscillations are produced by the interactions between populations of at least 2 different species, like predation, parasitic infection, and food availability fluctuations. However, density-dependent factors don't always create oscillations unless the right conditions are met.